Good afternoon to all. Today I will discuss about solid state welding process. Now I will discuss resistance welding. In case of resistance welding, that is the very oldest method of the electric welding process, and that will be also used in case of manufacturing industry. That welding process generally made of combination of heat, pressure and time. Means in that welding process we provide the power supply, and due to providing the power supply to the workpiece and electrode, heat will be generated, and due to heating, the melting portion of that weld faces, that will be sometimes it will be melted, and due to melting we provide the pressure, and due to pressure the both the weld faces that will be joined. And in that process easily we can join the two materials also. How much current will be determined by number of factors. How much current will be provided in that welding process, that will be depends upon the material thickness, material resistivity, current level and cross sectional area of the electrode tips and contact surface. Based on that factors we decided the how much current will be flow. Some simple diagram of the resistance welding. So here we have seen that is the both are copper electrodes, that both copper electrodes, that are the both are copper electrodes. Okay, that is the movable arm, that is movable arm, it will up and down, it will possible, but that is the fixed arm. Okay, and that will be held by some stationary arm is there. Using that stationary arm we hold that particular electrodes, and between that two electrodes we hold the workpiece, both the workpiece. And using that process, when we, that is the transformer portion, using that transformer portion that will be connected to the AC power supply. When sometimes in that transformer we use some rectifier, that rectifier helps to convert AC current to DC current. Okay, so in that cases using transformer we provide the power supply, both the electrodes. Okay, and providing the current power supply to that electrodes, it will create some pressure, and due to creating some pressure, that portion, that particular mating portion of that plate, some portion may be converted into plastic state or it will converted into molten state, and due to continuous pressing that both the plate will be joined. Okay, near about voltage we have used 0.5 to 10 volt, and high current near about 1000 ampere to 1 lakh ampere current we have used that resistance welding process. In case of resistance welding, that welding, using that welding, the joining will be produced by the heat obtained from the resistance of the workpiece to electric current in a circuit. Means when we providing the current between that mating surface of the workpiece, very high, due to flowing of the high current, the more heat will be generated between the two mating surfaces. Okay, here pressure is used for joining of the both the plated, and no filler material we have used in that cases. What amount of heat will be generated due to supplying heat, due to supplying power supply, so that will be calculated by the Joule's formula. Means energy H equals to I square RT. I means flowing current, R means resistance, and T means time. Okay, time during which the current flow in second. And very high current we have used near about 1000 to 10,000 ampere, and voltage we have used 0.5 to 10 volt we have used in that process. In case of resistance welding, the metals having higher thermal conductivity is difficult to weld. Means some metals has higher thermal conductivity. So in that cases, that is very difficult to weld using that welding process. Higher heat concentration on them means aluminium, copper. Some strength of that weld, that will be depends upon the surface roughness, cleanness of the metal surface. Means the generated weld using resistance welding, so in that cases the quality of the weld, that will be depends upon the surface roughness of the weld faces, another is cleanness of the weld surface. And before welding we remove the weld films, paint, oxide layers, that will be removed. Means if that things are present to the weld face, the quality of the weld after welding deteriorated. Resistance spot welding. What happens in that welding process? Means two bar type metal electrode which apply pressure. Two bar type metal plates are kept. Okay. Near about pressure we have given 2 kilonewton. Okay. Electric current is passed through that two electrode. Okay. Surface area of that metal in the center is more highly heated, and so it becomes plastic state, and then the current switch of pressure we applied in the weld spot or nugget has solidified. Means here both the metal is there and that is the electrodes, and that electrodes are connected to the transformer. Okay, and using that transformer we providing the current to that particular electrodes. Okay, after certain time we force apply and then we switch on the current. After certain time at the melting portion very high heat will be generated, and due to very high heat what happens now, in between that plated the molten state will be generated, and due to that molten state, that will due to applying pressure both the metal plate will be joined. Means here weld nugget will be created. Means that is one type of lap joint, and that both are electrodes. Okay, means after joining then we release the force. Now that is the resistance spot welding process. In that process we are seeing that is the electrode, upper electrode, that is the lower electrode, and using that electrodes we applying the pressure. Okay, and both the electrodes we supplying the cooling water for controlling the temperature on that particular electrodes, and that is the workpiece. And due to supplying, that is the power supply unit, and due to supplying the power to that both the electrodes, in that cases both in that melting surface of that plate the nugget zone will be created, means molten state will be created, and due to creation of the molten state and when we applying the pressure, that in across this surface both the plate will be joined. Resistance spot welding. In that cases spot diameter depends on the electrode diameter, near about varies from 3 to 6 mm, and electrode must be good electrical and thermal conductivity. Means using that thing the heat properly conducted to the workpiece plate, and also electrodes are cold rolled copper with some cadmium chromium alloy that will mix to that particular electrodes also. To prevent overheating, sometimes we have used some cooling water. Okay, 10,000 current applied in case of steel, and 13,000 ampere current will be applied in case of aluminium. And resistance spot welding applications, generally 8,000 to 10,000 spot in a single car we have, using that spot welding process easily we weld it. Cook wire, railways, spot welding also used to restricted 3.2 mm thick steel and 4 mm maximum thick steel plate we have welded using that welding process. 3.2 2 millimeter thick steel and 4 millimeter thick in case of aluminium. That is the resistance seam welding. And in that process we have seen that will show the resistance welding, that is both the electrode, and that will automatically control near about numerical control device, computer numerical control device, means a bunch of plate we kept, and using upper electrode it will give the pressure of that bunch of plate, and when giving the pressure in that particular portion, that will be converted into molten state, and due to converting of the molten state and providing the pressure, due to providing the pressure, both the bunch of plate will be joint. That is the resistance welding. That is the resistance welding. In case of resistance spot welding, both the electrodes, that are the electrode of that resistance spot welding setup, both the plates we have kept, means a particular places we have joined that both the plates, means spot, one particular spot will be created, and in that particular spot we have joined both the plates, both the electrodes, and using that electrodes we joined in that particular portion, providing the power supply, and due to providing the power supply, here molten state will be converted, and due to generation of the molten state, and in that particular weld faces, that will be joint.